Welcome back to the lecture series in cell culture. So, in the last class where we just ended was about myelination. So, today the first thing we will do, we will talk about how the myelination happens in the peripheral system as well as in the central system, and they have a very different pattern of myelination. So, if you are culturing peripheral neurons, then you have to follow a different paradigm as compared to if you are following a central nervous system neuron. So, in the peripheral neurons, when I drew this, we are into week 6, lecture 2. W6L2. Now, when you talk about the peripheral neurons, so this is a neuron, the way the myelination happens when these neurons are formed in the body is, there are these Schwann cells, and this is all about PNS. Okay, these Schwann cells arrive at the axon and as well as the dendrites, because this myelination you will see here too, right. Okay. So, these Schwann cells which are involved in myelination, these are type of glial cells, they will arrive along the cell body or along the processes. Now, out here what they will do, they will divide after reaching something like this. Upon division, these cells kind of go underneath the axon and tries to encircle it or tries to form a cover like this. So, for example, if this is the axon which is sitting, first of all these cells divide and some of them goes down and slowly takes it like this, as if it is forming a, just taking it in a grip like this, okay, something like this. And then what happens, these cells, individual cells which has formed a complete covering like that, starts to secrete a myelin basic protein which is called MBP or myelin basic protein. And it is this myelin protein which is secreted by these cells which form the myelin sheath around them, and most of these cells loses part of their identity. So, the fate of these cells are like this, initially they are like this and eventually they become something like this. It seems as if the boundary of cell membrane kind of merges, the cell membrane merges, it looks like a complete sheet kind of structure. That is why it is also called myelin sheath, and the sheet kind of anchors on the axon by virtue of these secreted myelin basic protein. Now, having said this, having give you a very small flair of the biology here, now I say that you want to culture neurons. Sure, you want to culture peripheral neurons, but then you have to know, could you achieve this? How you are going to do this? Think of it. Okay. Now, I will give you two case studies before, again remember that do not lose the sight of this fact, adult hippocampal dissociated cell, this is where we are heading, but before we head into this, there are several other things what I expect you guys should think, that why these kind of cell culture models are so very important. So, this is one problem which boggled us for a while, and I was very fortunate to work with a very close friend of mine who has pioneered this technique of developing myelination sheet on a peripheral neuron in an in vitro culture. I will share this. His name is John Wayne Ramsey, was one of the gentlemen in University of Central Florida, where I was working with him on his thesis problem, and this is the problem what he solved in his thesis. one of the problems. He solved many other problems, but this is one of the problems. So, how he did it? In a dish. So, I will share the real time experience of how he actually did it. Okay. So, the way John approached the problem was very interesting. So, the first thing what he did, so for peripheral neurons, what are the sources? And please do not lose track that we have to come back. I am just diverting from the main course in order to come back there with a much more concrete viewpoints about you people, that why we have to answer these kind of peripheral questions before we target onto some of the very, very challenging problems of the future, regeneration of the adult neurons, and in a culture dish, how we, especially in a culture dish, how we can minimize the financial burden of drug discovery. Okay. So, now getting back, how this problem was targeted. So, the first and foremost idea, let us break the problem, achieving, so the title is achieving myelination in a dish with peripheral neuron. So, second, if this is what you want to achieve, why? A test bed for studying myelinating disorders, sclerosis, where myelination is destroyed. So, you have why, what, and let me in vitro setup or in vitro test bed. So, this is your what, this is your why. Now comes how you achieve it, and this is what we are going to discuss now for next 15 minutes, how you can create such a test bed. Before we say how, let's try to figure out what are the requirements, what are the prerequisite or requirement. So, we are trying peripheral neurons. Your easiest source of peripheral neuron will be dorsal root ganglionic neurons, which are sensory neurons, this is one of the prerequisites you need. And how you can obtain dorsal root from where? One of the easiest model, at least what we have worked for the years, is you get it from rat. They have a fairly good, especially from embryonic rat, which is E14. So, generally rats have this 22 23 days of pregnancy. So, you can get one from E14 dorsal root ganglion. So, we are not trying to do it on adult, because this was the very, very first cut, one has to try it out. Embryonic neuron E14. So, from E14, so if you look at how you are going to isolate. So, there is a dissection challenge here. Dissection challenge is you are handling an embryo which will be very teeny tiny, something like this. Now, first thing what you have to do is you have to isolate the spinal cord, and this has to be a microsurgery, and around the spinal cord you will see this dorsal root ganglions sitting, and very craftfully, extremely craftfully, you have to, using your surgical acumen, you have to isolate these dorsal root ganglions separately. These are individual ganglions. Okay. So, now what you have your the collection buffer, something like hibernate or something, you have these dorsal root ganglions, DRGs. Now, these DRGs needed to be enzymatically dissociated, so that, so you can do an enzymatic dissociation by using trypsin, or if you are really good you can do it manually also, but you have to be really careful while doing it manually, and most of the enzymatic dissociation are done with trypsin. You can try out papain, but it is worth trying out trypsin. Okay. And if you use trypsin, then you have to stop this trypsin reaction within, after 10 to 15 minutes, using something called trypsin inhibitor, because trypsin is going to damage the cell. So, you have to ensure that that reaction happens of, when we talk about these kind of ganglions, these ganglions have something like this. It's a lot of cells which are sitting there. So, what you are essentially doing while you are putting trypsin, you are trying to separate out the cells by penetrating in between, like this. So, what you are getting are single cell suspension. So, and these are your DRG neurons which are there at E14, because if you go further, that the population of the Schwann cells are going to go up. So, here one interesting thing one has to realize, that the first first cells on the DRGs are the sensory neurons, followed by, once the sensory neurons are formed, simultaneously the Schwann cells are formed and they form the wrapping. It is not that what these wrapping as well as these this division of the Schwann cells to form that covering is happening parallelly. First of all, they hit their target and simultaneously this process starts. So, once you get at this kind of single suspension, you have your first set of prerequisite ready, that is, you have the peripheral neuron at your disposal, but now you want to achieve another thing. So, this is, if this is the first prerequisite, there is a second prerequisite. Second prerequisite is that you will be needing the Schwann cells, because you want to myelinate, and this is, you are doing a peripheral myelination. So, in order to do that, you need a source of Schwann cells, but I just now mentioned you that when you use a E14, at that time the Schwann cell hasn't formed properly. So, it means in order to obtain a Schwann cells, your source, animal source, has to be a mature animal. So, your option is that you get a Schwann cells from adult, but it does not work. But what you can do for Schwann cells, you can take a P1 or P4 rat. What is P1 and P4? So, I told you that the pregnancy goes up to, say, E23, 23 days. So, as soon as they are born, this is P0, this is the day we born, and it's P1, P2, postnatal. So, around something around P1 to P2 or P4 postnatal after birth, those teeny tiny rats, those are the source of Schwann cells. They work the best. Now, if you ask me that how all these things are known, it is 100 years or last 50, 60 years people are being working. So, it is kind of a long haul journey. So, today we have some ideas how where we could get those cells which are going to myelinate and likewise so on and so forth. So, it all comes through some of the very critical studies in development biology, in vitro development biology. So, we have an idea that at what point these cells will appear and how that information of developmental biology could be exploited to develop an in vitro setup. So, these all things are very interlinked. So, this whole area of cell culture, especially any kind of cell culture, one has to have a kind of idea about the development problems too. Without that, it will be very tricky. It will be something like, yes, I know and yet I do not know. You understand my point? So, it is very, very kind of, I would say that essential that you keep your eyes open, that you know what all the basic developments are happening. Now, think of it. Like I still remember we used to think that if we could get the Schwann cells off from that age, but unfortunately the development does not allow us to do so. So, we have to depend on another animal or another age group animal to get the Schwann cells. So, now that is your second source to isolate the Schwann cells. So, now once you get the Schwann cells which are like kind of this kind of shape, okay. Now, we realize a very interesting thing, that when you talk about the Schwann cells, they will be dividing. These are dividing cells, whereas, so this is a form of glial cells, okay. Whereas neurons, what we will be dealing with are non-dividing. But now, if you put a non-dividing cell with a dividing cell in a culture, and without ensuring that the dividing cells arrest this division, the dividing cell will outnumber the non-dividing cells, and so much so that you lose tab on the problem, that you know you won't be able to even locate the non-dividing cell. So, how to target the problem? One of the ways one can target the problem is, you first of all plate these cells. Which cells? The non-dividing cells. So, you have a dish out here, and this is how we achieve the problem or kind of targeted the problem. So, you plate these peripheral dorsal root ganglionic neurons in a dish. You will see within 24 hours or so, they will start sending out the processes like this. And then one of the processes will become larger and will form an axon. You allow that part to happen. So, you have the process in front of you now. And if you can pattern them to follow a geometry, that will be even better, if you can really do that. Now, as they are growing after 2-3 days, this is the right time to introduce the Schwann cells. So, these ones you are achieving from the E14, right, non-dividing cells. So, now they have formed their processes, okay, something like this. Now, at this stage you are about to introduce the Schwann cells. So, I will close in here. We will continue this story after that, what will happen and how you can translate it to the adult hippocampal neuron, because there are some missing wonderful links. Okay. Thank you.